Okay, now recording. And let me share the screen. Okay, so we're over here. I'm actually finished with 3.9, so I'm going to start 3.10 today, so I'm slightly ahead. So I won't do that much today, and then we'll take the quiz. Okay, so I'll quickly review the formulas and such that you need, and then we'll do some of the problems from 3.10. And by the way, after today, we're on this side of the paper, so you know we're getting there more than halfway, right? So, you know, when you look at this sheet, you've got this side and this side. So now we've reached the end of this side. So after this, we're more than halfway, right? Okay. And one other quick reminder announcement. I sent a Canvas announcement. So one of your classmates, Madeline Quinn, asked me to send out an announcement for a possible study group and propose schedule for studying for the exam. So you can do with it as you wish, or contact her if you would like to. Okay, so that's that. All right, so we're doing 3.10. The assignment for 3.10 is 1 to 33 odd. So I'll show you those problems. Again, on page 256, for those of you who don't have the book and aren't getting it. There's that. Okay, now the first problems, while I'm showing this to you, the first problems are really just equation of the tangent of the curve, but keep going, write it as y equals mx plus b, more specifically, L of x. You can write something called L of x, L standing for linearization. Okay, the linearization of a function. And how far do we have to go? 33. And there's 33. Okay. So again, for this section, what do you need to know, or what do you really need to know? Okay, so you can have equations 1 and 2, but in my opinion, you don't need either one. It's almost like for number 2, you just want to blindly follow a formula. You can use it. Okay, essentially what it is the equation of the tangent line, which you've done many times, but just solve for y. And when you finally get to y, I call that L of x, the linearization function. It's a linear approximation of the function. Okay, the only other one you need is this formula for differentials on page 254, equation 3, dy equals f prime of x dx. And it's a variation of the Leibniz notation on the left-hand side there, right? We know dy dx is a symbol for derivative equals f prime of x. If you were to multiply both sides by dx, right, then it's going to look like that. dy equals f prime of x dx. Okay, and again, that's all you need for 310. And quickly for 3.11, for hyperbolics, which I'm not talking about today, but next week. So hyperbolic functions on page 259. All of these, the ones you really want to focus on are sinh and cosh, e to the x minus e to the negative x over 2, and e to the x plus e to the negative x over 2. The others, it just follows the rules from trig. Okay, hyperbolic tangent is hyperbolic sine over cosine, and reciprocal of hyperbolic sine is hyperbolic cosecant, and so on, just like in trig. Okay, so you take the 6 trig functions and put an h after it, right? And then the only other ones you need are these 3 derivatives on page 261, hyperbolic sinh, cosh, and tangent. Okay, so you don't need any of these, and you don't need anything else in the chapter. There's a lot of other stuff, sorry, in that section. There's a lot of other formulas in the section. Don't worry about any of them. Okay, now I might ask you stuff for, like some of the problems ask for proofs of these identities, so don't memorize them, but you should be able to do them, so to speak. Okay, so here we go. How to do some of the stuff from 3.10. So find the linearization. It's just like saying find the equation of the tangent line, solve for y, call it L of x. Okay, and a heads up, for 7 and 9, they're really the same kind of problem. See where 7 and 9, it's got the squiggly equal, which means approximately equal. The right-hand side is the back of the book, essentially. Okay, so treat 7 and 9 as saying give the linear approximation at a equals 0. Pretend it's like 1, 3, and 5, and the back of the book for number 7 says x, and the back of the book for number 9 says 1 plus half x. Okay. And there's some problems involving differentials. They're very straightforward. Okay. The left side, you just put dy. The right side, you take the derivative and put dx. Okay. And I'll show you what I'm talking about for a few of these. And then after a while, I'll stop and give you the quiz. Okay. Let me check the chat. I think some people just joined. Yeah. Okay. So that's fine. Anybody who joins late, yeah, let me know so I can mark you for attendance. Okay. So I left off finishing the last section on related rates. So linearization of a function, it's the equation of the tangent line written as a function, L of x equals mx plus b. So you're already familiar with y minus y1 equals m times x minus x1. And then I said stop. Okay, now we're not stopping. Keep going like in algebra 1. Solve for y. So an example final answer, L of x is negative 3x plus 10. Solve for y, clean it up, call it L of x as a function. Okay, and we're using L of x as an approximation to the function in some of the problems. Okay, so I'll show you what I mean now. So here we go. Okay, question 3. F of x is the square root of x at a equals 4. Okay, and somebody just joined. Okay, that's the quiz is on exponential growth and decay. Somebody was asking. I think that was what, section 8. Yeah, section 8. All right, square root function at a equals 4. So what's a? A is a particular x value. Okay. They don't give me the y. That's easy. Just plug in. Square root of 4 is 2. So 4 comma 2. Okay. So what are we really doing? If we can just sneak this in real quickly, square root function looks something like that, right? Here's some point 42. What's the equation of that tangent line at the point 42? That would be a linear approximation. Okay, so we've played this game before. Take the derivative. Derivative of x to the 1/2, which is square root of x, is 1/2 x to the negative 1/2, which is 1 over 2 radical x, right? Negative 1/2 means put a square root in the bottom. Plug in 4, put a 4 right there, 1 over 2 radical 4, 1 over 2 times 2, 1/4. Okay, point, slope. Okay, so we've played this game before. Y minus y1 equals m times x minus x1. Okay, only now keep going. Isolate the y and call it L of x, standing for linearization. So that's not really that big a deal. Okay, so distribute y minus 2 equals 1/4 x minus 1. Add 2 to both sides. So final answer, y is L of x is 1/4 x plus 1. Okay. We isolate the y to make it look like a function. Okay, so this tangent line is 1/4 x plus 1, which means the problem's finished. But for this square root function, if you want an approximation to the square root function near a equals 4, use this instead. Why? We like straight lines. Straight lines are very easy compared to square roots and trig and log and exponential and all that kind of stuff. Okay. Okay, here's another number 5. Square root of 1 minus x at the point 0, 1. They didn't have to give you the 1. You could have figured that out. Okay. And after that, they are saying for number 5, use the linear approximation to approximate square root of 0.9 and square root of 0.99. Okay. Technically without a calculator. Okay, so how do you do that? Okay, so take the derivative, 1/2, 1 minus x to the negative 1/2, then by the chain root times the derivative of the inside, which is negative 1. Clean it up, negative 1 over 2 radical 1 minus x. Plug in 0. You're at 0 comma 1. So it's negative 1 over 2 radical 1, negative 1/2. Okay, our familiar point slope form. Point, slope. Y minus 1 equals m times x minus 0. X minus 0 is x, right? So just add 1. So y equals L of x is negative a half x plus 1. Ultimately, what are we saying? My approximation for this function near x equals 0 is to use this, which is a much, much nicer function than this, right? We like straight lines. We don't like square roots that much, okay? Then in the problem, they ask you to use this linearization function to approximate the square root of 0.9 and the square root of 0.99, okay? So how do I do that? So here's the function. To take the square root of 0.9, so behind my finger should be 0.9, right? So how do I force this expression to be 0.9? It's 1 minus 0.1, right? And likewise, they asked me to approximate square root of 0.99. So behind my finger, I want 0.99. So 1 minus x, 1 minus what number is 0.99? It's 1 minus 0.01. So the function value that I'm plugging in are 0.1 and 0.01, in other words. Okay, so instead of plugging into a square root, which I'm not as comfortable with, obviously, I plug into the straight line function, the linear approximation, negative half x plus 1. Okay, so L of 0.1, I plug in 0.1 right there, comes out to be 0.95. i.e., my guess for the square root of 0.9, without even using a calculator, is 0.95. And do the same thing for 0.01. Okay, so square root of 0.99, again, you're plugging in 0.01 here because 1 minus 0.01 is 0.99. Okay, so I plug in 0.01, negative a half times 0.01 plus 1, 0.995. Okay, so my approximation for the square root of 0.99 is 0.995. Okay, the problem's finished, but just for fun, just compare this. You can actually punch this in your calculator. Square root of 0.9 comes out to be 0.9487. My approximation was 0.95, pretty good. And if you punch this in your calculator, square root of 0.99, it comes out to be 0.99499, which is very close to 0.995. Okay, so that's how you do number 5. Okay, then again, problems 7 and 9, they're not really that big a deal. Okay, the right-hand side's the back of the book. So verify the given approximation at a equals 0. You're going to plug in 0. You can't get any better than plugging in 0. And the back of the book is the right side. Okay. So for number 7, sorry, that should be a 7 there. F of x equals natural log of 1 plus x. It said plug in a is 0. If you plug in 0, you're taking a natural log of 1, which is 0. So you're at the origin. So what's the derivative of this thing? 1 over 1 plus x. Times the derivative of the inside, but that's just 1. Okay, now I plug in 0. 1 over 1 is 1. So the point is the origin. Can't get any better than that. Slope is 1. Y minus 0 equals 1 times x minus 0. So y equals f of x, or L of x. We now use L of x. It's just x. And that's the right-hand side of that squiggly equal sign there. Okay. All right, so that's that. All right. Can we have some problems involving differentials? I'll do a couple of those and then we'll stop. Find the differential of each function, okay? It's not that bad because, look up at this, equation 3. The left side, you just put dy or d whatever equals, take the derivative of the right-hand side and just put a dx or whatever the letter happens to be. Okay, so I'll show you a few of those. And then that's pretty much about it. Okay, and yeah, some of you just joined. If you joined late, just let me know, put it in the chat. Okay, y equals x e to negative 4x for 11a. So to do these problems, put dy on the left side, the derivative here, and then dx. You're really just taking a derivative. I mean, think of it this way. Suppose I just put dy dx. You're taking a derivative. Then the derivative is blah, blah, blah. Then multiply both sides by dx, and it looks like that. So you're essentially just doing a product rule and a chain rule here, right? Okay, so product rule, first function x times the derivative of the second. So what's the derivative of e to the negative 4x? E to the negative 4x times negative 4, chain rule, derivative of the exponent. Plus the second function, e to the negative 4x, times the derivative of the first. Derivative of x is just 1. So that's it. Just a little bit of touch up maybe. So I put the negative 4 in front. So dy equals parentheses. You do need the parentheses. It's all this stuff times dx. So negative 4x e to negative 4x plus e to negative 4x dx. Okay. Then some future problems, not today, but probably Monday, you'll be plugging in stuff. They'll tell you, okay, dx is, I don't know, 0.1 and x is 2, and plug it all in, and what is dy? That's all. Okay, 13b, y equals 1 minus v squared over 1 plus v squared. So it looks like the quotient root. Okay, so again, all you do for these problems is this side put dy, take the derivative, and normally I would say dx, but this time they put a v, so just put dv, that's all. And right behind my ruler here, you take the derivative. So here we go. Bottom times the derivative of the top. Derivative of the top is negative 2v minus the top, 1 minus v squared, times the derivative of the bottom, 2v, all over the bottom squared, 1 plus v squared squared. Okay, and then a little bit of touch up I distributed here. So negative 2v times that, so negative 2v minus 2v cubed. And then you got to be careful here. It's a negative 2v, and then there's going to be a double negative. It's minus, okay, this minus here, minus 2v times negative v squared. It's a positive 2v cubed. So negative 2v cubed cancels a positive 2v cubed, and negative 2v and a negative 2v, so negative 4v. So final answer, dy is negative 4v over 1 plus v squared squared dv. Okay, and I was going to stop there. Okay, but just show you where we're heading. Okay, like I said, the next set of problems, you do the same stuff, and then you plug in. They tell you to plug in something for x and dx, and you're going to end up with some dy or whatever. Okay, so I'm going to do my focus thing real quickly for about a minute, and then I'll go ahead to the quiz unless anybody has a quick question. And if you join late, go ahead and put that in the chat so I can mark you for late attendance. So showing this to you so you can look at the video later in case you say, oh, it's too blurred. If I put it way down here, it's too blurry. So, okay, so in the meantime, if anybody has a question, go ahead and put it in the chat or unmute yourself. If not, we'll get ready for the quiz in about 10 seconds. That. Okay, I'll stop there. So I'll pick up from here, problem 17 next time. All right, so any quick questions? Otherwise, we'll go straight to the quiz, please. Okay, I don't see anything or hear anything, so we'll get started. All right, so get your cell phones out or be ready to do a screenshot. Here we go. Okay, the half-life of a certain substance is 11 days. Number one, If we started with 100 grams of the substance, how much remains after 30 days? 2, how long would it take for there to be 70 grams remaining of the substance? Okay, so the first thing you want to do is solve for K, figure out the K. Hint is, what do you do with a half-life? Okay, solve for K. Once you have the K, you can work with here and work with here also. As usual, put your first and last name and everybody in your breakout room's first and last name of everybody. And don't leave right away if you get the answer. Make sure all your team members get it. So again, I will look at all of them, but I'll only grade 1. So the only way you can be sure to get it right is to make sure everybody in your group gets it right. Then of course it doesn't matter whose quiz I look at, then you should get full credit, which has been happening most of the time. All right, so I'll make this disappear in a few more seconds. I'll assume everybody has it. Go ahead and get started and give me a moment to set up your breakout rooms, and that'll be it. Then have a good weekend. Okay, I will now assume that everybody has it. Okay, so the first thing you want to do is solve for K, figure out where to plug in stuff. Okay, what do you do with 11? What do you do with a half-life? And so on. Okay, I'll stop the share. I'll stop recording also.